So for a really long time, the Cold Fusion runtime has had this concept of CFThread. And CFThread is a seamless, effortless way to run asynchronous code inside of a Cold Fusion application. But it's kind of a fire and forget type of mentality. It does its thing and then the thread exits. And since CFThread was introduced, I've sort of wanted a more persistent version of CFThread, something that would not only run asynchronously, but would run persistently in the background. So for example, here I have a Redis instance and I'm pushing messages onto this list at the key Demo. And what would be great is to have a sort of CFthread way to sit in the background, monitor for values on this list, and then consume them. And of course you could replace Redis with some sort of message queue like SQS from Amazon, RabbitMQ, so on and so forth. And again, CFthread allows us to run things asynchronously, but it doesn't necessarily allow us to run things persistently, right? Because now I might want to have a consumer that exposes a run method, and you can see will actually look for messages on that key. So Redis list key here is this ben.demo. So my producer here is pushing messages onto this, and I have this consumer in the background that's going to be listening for messages, and the B here stands for blocking. So it's going to block for up to 5 seconds, listening for messages on that key. If I get them, I'm going to log them to the output. And then what you can see is this is all just inside of a while loop. So essentially the consumer is going to be sitting there, blocking and listening, running this while loop until it's told to stop. Now, that's great at first, but what you realize, or what you eventually find out, is that this is a very unstable approach because threads can die for all sorts of reasons. They've been killed manually in an APM application like Fusion Reactor, or they can just have a bug in them that crashes them, or an edge case, right? So for example, if I push on the message crash, this demo code here is going to throw an error, and that's going to kill this while loop and would kill any CF thread that might be running it, assuming it's not inside of a try-catch itself. So what we want is something that not only runs this asynchronously, but ensures that it's running over a long period of time. So let's take a look at what this might look like. So here's our console output, and here's our application, and let's start up our application. And let's just look at this to see what happened here. So the first thing happened, we can see that the CFML application is bootstrapped. We have this thing called a background runner, which we'll look at in a moment. Here is our consumer. You can see it's looking for Redis with a blocking operation. It waits for 5 seconds. It didn't find it, so it times out, and then it's in a while loop, so it then continues to block again. And now what we can see is we can put in some values here. You can see hello world, and the consumer found those, logged them to the output. See test, blam, Coolio, so on and so forth, right? So the consumer is running. Now let's try and put in that special keyword crash, which again, for the demo, will just turn around and crash the consumer. So if we do crash, we can see that message pulled off the list there was crash. We threw an error. This background runner saw that it was ended in error, and then what you can see is that the background runner started the runnable again. And here we have our consumer that's looking for messages, and we can say, I am alive. And you can see, there we go, right? And we can do crash again, and it crashed, started up, and then we can say test. So what is this background runner? What is this thing that's actually turning around and making sure that this consumer is persisting over a long period of time? And what that is a task thread, which is a version of CFthread that runs outside of the Cold Fusion application, and it's going to call back in to our application to make sure that the consumer is running. So let's kill this. We can stop it, and you can see here the CFML application is shutting down. The background runner is stopping the background thread. It's stopping all the runnables, and here we can see that the consumer doesn't start up again after its last blocking operation. So let's poke around. So if we look in the application pool, you can see I have my Redis abstraction. I'm creating an instance of the consumer, which I'm passing the Redis pool to. We've already looked at that code. It's not super important. It's this background thread runner, which is going to be the main focus here. And what you can see is that I'm taking the background thread runner and I'm saying run in the background, and I'm passing in this consumer. So it's going to expect anything that's passed to it to have a run method and a stop method. Right, so let's take a look now at what background thread runner is doing. So let us jump to the run in background. So the run in background method takes this runnable concept, right, which has a start and a run method. And what it's going to do is it's going to keep track of a list of entries, so a list of runnables essentially. Each runnable is going to have a instance, right? So this is a Cold Fusion component, so it's passing in a Cold Fusion component, and it's going to have a thread associated with it. And this is going to be an instance of the standard CF thread, the Daemon thread, the default type of thread, which will be null at first. So it's going to push this onto this collection, and it's going to ensure that this task thread is running. This is going to be that background, that really persistent background thread that's going to make sure that all of these other threads are running. We don't start this thread here. That's going to happen inside the ensure task thread. So let's jump down to ensure task thread. So the ensure task thread is going to create up this task thread in the background, a CF thread of type task. Now a CF thread of type task actually doesn't execute inside this Cold Fusion application context. It executes completely outside this application. I think it actually gets serialized to disk and then deserialized and executed. So it's completely decoupled from this application, which means we need a way for the task thread to communicate with the application that we're currently in, and for that I'm going to be using the server scope. All Cold Fusion code on the same server has access to the same server scope, so we can use this as an intermediate, sort of tunnel between the task thread and the typical Daemon threads. Now, the way this is going to work is a little tricky, so let's step through it really slowly. The complexity here is that when the task thread starts up, it's actually running inside a completely different application context, which means that if it tries to call a value that we've persisted to the server scope, that value is going to have a lot of unexpected behavior because of the way Cold Fusion actually binds variables to a particular piece of executing code. So to do this, what we're going to do is persist this struct to the server scope, and it's going to have two things. It's going to have this background thread runner instance, right? So this Cold Fusion component instance, and it's also going to use to persist this application context, which we're going to get out of the current page context. And this is the thing that sort of binds the runtime to the variables to the executing code. To be honest, this is way over my head. I don't really understand the low-level mechanics of it. I got this little tip out of the Lucee dev site from Mika with a conversation with Brad Wood. So what's going to happen now is that we're going to spin up a CFThread tag of type task, right? So typically this is of type Daemon. You never even need to tell the CFThread tag because that's just the default type. And what that is going to do is it's going to essentially take all this functionality, serialize it to disk, and then start trying to execute it on this retry interval. And our retry interval, you can see, is max integer, so it's like 2 billion something, right, I think. So if this thread were to crash, the Lucee task manager will just continue to try and run it again. And inside of our task thread, which remember is executing completely outside of the current Cold Fusion application context, what this does is it reaches into that shared server scope. It gets the runner, which is this Cold Fusion component instance. It gets the application context, which is what we stored here before we generated our task thread. And then it uses this page context.set application context to essentially bind the application context of our running application to the page context of our task thread. And it's this critical step which allows us to be able to call back into this parent application and get the expected behaviors and variable bindings when we call our persisted Cold Fusion component references. Now inside this task thread, once this is all set up, you can see we just have this indefinite while loop, which turns around and calls runner, which again is this Cold Fusion component instance that we're currently in, and it calls this kind of quasi by convention private method, which is actually public, but with underscore meaning don't use it. It's going to call this ensure runnables are running. And what that's going to do is loop over that list of entries that we saw earlier and make sure that all of those Daemon threads, right, the typical CF threads, that those are all running and wrapping and executing their other runnables, right, like the consumer is inside one of those runnables. So let's take a look now at what this is doing. So if we jump to that method, ensure runnables are running, we loop over that list of entries. We call ensure runnable is running for each one of those. So every single entry is actually going to end up running inside of its own typical Daemon CFThread instance. And let's jump down and see what that is. Ensure Runnable is running. You can see, so we have our entry, and every entry has an instance of Runnable thread, and that is the actual instance of the Daemon CFThread. And what we're going to say is if this entry doesn't have a thread yet, or if the thread appears to have completed, whether it's terminated or completed, meaning terminated in error, like an interruption. If that's the case, then what we're going to do is start it up again. We check here to see if it ended in error. If it did, we log the error. Otherwise, we say we're starting this Runnable with this particular ID. We give it a globally unique thread name because we can't start the same thread multiple times inside this particular page request. Otherwise, ColdFusion complains. And you can see at this point, we start a CFThread of type Daemon, and I could actually remove this altogether because type Daemon, again, is the default type. This is your typical fire and forget, runs once kind of a thread. And this turns around and calls the runnable.run. So the runnable in this case is the instance of our consumer, right, that's blocking and listening on the Redis list, right? And so essentially this is now a CF thread that itself will somewhat run indefinitely by coincidence because the run here happens to be inside of a while loop. So this is just going to hang in the background now and run until this thread gets interrupted or this consumer throws an error, right, which is what we're doing here if it sees the list value crash. And then what's going to happen is at that point, the thread, the Daemon thread that's managing this runnable is getting stored into this runnable thread, which means that the next time the background task goes to ensure that something is running, it will have the thread instance, but we'll see that the status is now probably completed or terminated, at which point it says, oh, okay, did this end in error? If it ended in error, log it, and then spin up another CFThread instance, and let's store that CFThread instance with the runnable. Now, one thing that's a little bit more challenging is how do we terminate this thread if we wanted to, right? So like in my application CFC, you can see in the on application end, I want to call stop, which would then turn around and stop all of the runnables that it's managing. Well, this is going to get called in a different page request than the thread that was initiated, and there's no real easy way in ColdFusion to stop a thread across two different page requests because they don't really see each other's threads in sort of a managed aspect. So to cope with that, what I'm doing is inside of the Daemon thread, I'm exposing a stop runnable method on the thread scope. And you can think of the thread scope as sort of being a tunnel between the exterior and interior context of the thread execution. So externally, I can access the thread scope, and then internally, I can expose things on that thread scope. And in this case, I'm exposing a method called stop runnable, which just turns around, references the runnable, and tells it to stop, right? And if we look at our consumer, and we look at the stop method here, you can see all it's doing is setting the isRunning to false, which if we look at our run function, is what will terminate this while loop. So it's not like the background runner is interrupting the CF thread that's running this runnable. Instead, it's just telling the runnable to stop. The runnable will stop. That will terminate the while loop, which will allow this run method to return, which will allow the CF thread execution to stop naturally. And because CF thread doesn't start up again on its own, right? It's kind of a single time fire and forget. That will allow this Daemon thread to exit naturally. And if, of course, if we start the application up, it starts with the background thread runner, which then starts this all over again. So again, I know it's like a lot to take in. Let's just run through it one more time here. So we have our, we shut down the Lucee. That stopped the background thread runner. You can see that the consumer was told to stop processing the Redis list, right? And again, that was stop processing Redis list. All that did was set the isRunning to false, which allowed the while loop in our run method to finish, which then put this message processing stopped, and you can see that right here. And because that stopped, essentially all of the application code is finished running. But now if we jump back in here and we start up our application, we can see bootstrapping the Lucee application. And actually, do I have, and here's my CF, let's look at the tasks. Here's my web context, and you can see here is that task runner running. And if we jump back into here and we stop the application, right, we can see Lucee shut down. If we jump back into our task runner refresh, you can see that that task is gone. So we're using that task thread in the background, again, to power this background task runner, which is in turn managing the existence of normal Daemon CF threads. Right? Start it up. Hello. See the message. World. All is good. Super awesome. CFThread is so hot. Right? And then crash. And there we crash. Background thread runner is starting up the runnable with ID, and again the consumer is back in play. So I'm sure that there's definitely some, stability issues here. One thing that I wonder about is if we look in the ensure runnable is running, we spin up our thread here, and then we store that thread instance. I have to imagine there's some sort of race condition in here where like maybe the code could crash here somehow. I don't know how, but essentially maybe this could crash before I'm able to store the instance of the thread, which may end up kicking off like multiple versions of this runner at the same time. I'm not exactly sure. I mean, it'd be great if ColdFusion just had something that did this for us manually. Obviously, we have scheduled tasks. We've had those, I think, forever in ColdFusion that would allow us to call back into the application. The thing that I don't love about scheduled tasks is they're not really user-friendly to set up within the application. What I love about this is that this is like all native ColdFusion, and by native ColdFusion I mean like it's core application processing. It's not like I'm using the CF administrator API to programmatically set things up in the administrator. I'm actually just using vanilla ColdFusion code to get this all to work, right? Nothing being called outside. I don't need like a username and password for the administrator to set this up, right? This is all just like normal vanilla, no special access code, right? I have my CF thread here of type task and so on and so forth. Anyway, I just thought this was like a really interesting experiment. Task I don't believe exists in Adobe ColdFusion. I don't know how long it's existed in Lucee CFML. And frankly, when I learned about it, I couldn't think of an actual use case for it, especially because of like all of this shenanigans where it's not actually running as part of the ColdFusion application. So like, what's the point? But now that I learned this little trick where you can actually reassociate the running task thread with the parent ColdFusion application context, granted, right, we're using a lot of shenanigans here with the server, the shared server scope, but I think that does open up some like really interesting opportunities to create persistent background threads that don't necessarily rely on external configurations like a cron job or a scheduled task. And I don't know, I'm kind of excited about it. I'd love to have more of a conversation with people who know more about how this works at the low level. And maybe there's a much easier way to do this using the like dipping down to the Java layer. So anyway, a lot of fun. And if anybody has any thoughts or insights or recommendations for improvements, please let me know.